Hello everyone, this is Navdha Soni, Assistant Professor in the Department of Quality Assurance at LG Institute of Pharmacy. Welcome to the MOOC series, initiative taken by LG Institute of Pharmacy, Ahmedabad. In today's session, we will discuss about flame emission and atomic absorption spectroscopy. So, first starting with the introduction. First of all, one question will arise: what is atomic spectroscopy? Okay, so the atomic spectroscopy is oldest instrumental method for the determination of the elements. When we want to determine the elements in particular compound, we have to use this atomic spectroscopy. Right. These techniques are introduced in the mid of the 19th century, during which Kirchhoff and Bunsen showed that the radiation emitted from the flame depends on the characteristic element present in the flame. The developments in the instrumentation area leads to the widespread application of atomic spectroscopy. Okay. When the absorption and emission of radiant energy by the particular atoms, which provide powerful analytical tools for both quantitative as well as qualitative analysis of the substances. Flame emission spectroscopy, it is the method of chemical analysis that uses intensity of light emitted from the flame. Okay, this technique will use the intensity of light which is emitted from the flame, arc or spark at that particular wavelength to determine the quantity of element in the sample. So we can conclude that how much quantity of elements are present in the sample. Okay, the basis of that flame photometric working is that the species of alkali metals group 1 and alkaline earth metal, that is group 2 metals, okay, are dissociated due to the thermal energy provided by the flame source itself. Due to this thermal excitation, some of the atoms are excited to the higher energy level where they are not stable. Okay, as we know that when any excitation occurs, the atoms are transferred to a lower level to higher level. Okay, so here same case, due to the thermal excitation, some of the atoms are excited to the higher energy level where they are not stable, so they returns to the ground level itself. Okay, so the absorbance of light due to the electrons excitation can be measured by using the direct absorption technique. The subsequent loss of energy will result in the movement of excited atoms to the lower energy ground state with emission of some radiations. Okay, which can be visualized in the visible region of the spectrum. The intensity of radiation emitted by these excited atoms returning to the ground state provides a basis of analytical determination in the FES, that is flame emission spectroscopy. And the wavelength of emitted light is specific for the specific element. Means the wavelength of that particular emitted light is specific for the specific element. Okay, in the flame emission spectroscopy, the wavelength of spectral lines give identity of element. Means every element having different spectral lines. Okay, so wavelength of spectral lines give identity to the elements, and intensity of emitted light is directly proportional to the numbers of atoms are present. Here you can see the instrumentation of the flame photometer. You can see the sample delivery system via nebulizer. The compound are mix up with each other, and one flame or burner. Through burner flame is there. Okay, and energy is transferred to the various components like monochromator, filters, detectors, and after that amplifier. Okay, so this is the schematic representation of the flame photometer. First of all, first part of that instrumentation, that is atomizer and nebulizer. So what is it? The process of conversion of sample to fine mist. Okay, the sample is converted into the fine mist by the atomizer and nebulizer. So the process of conversion of sample to fine mist or finely divided droplets using the jet of the compressed gas, and the pneumatic nebulizers, electrothermal vaporizers, or ultrasound nebulizers. These are the various types of the nebulizer. That is pneumatic nebulizer. That are the pneumatic nebulizers, electrothermal vaporizer or nebulizer, and ultrasonic nebulizers. Second most important part, that is burner. And they must have ability to evaporate the liquid when we are mixing the sample, and in smaller droplets in the flame of burner, they are evaporated. Okay, so they must have ability to evaporate that liquid droplets from the sample solution and capacity to excite atoms form and cause them to emit radiant energy. Various type of burners are available in the market, that is Macu burner, total consumption burner, laminar flow burner, shielded burner, Landgraf burners. These are the various types of burner which are used in the flame photometer. Okay. Monochromator, in the UV spectroscopy, you have familiar with this word, that is monochromator, right? They disappear the radiation coming from the flame and falling out, right? And dispersed radiation goes to the detector from the exit slit. You know about the slit, right? So dispersed radiation goes to the detector from exit slit. Filter fusion has wavelength range transparent to emission from element of the interest. Detectors which detect the particular atoms, right? So photoemissive cells or photomultiplier tubes, you know about the photoemissive cells and photomultiplier tubes because you have already studied about the UV spectroscopy as well as infrared spectroscopy, right? So photoemissive cells and photomultiplier tubes are the widely used, and they measures the intensity of radiations falling on it. Amplifier and readout devices, it is suitably amplify and display detectors output. Amplifier sensitivity can be changed to be able to analyze sample of the varying concentrations. Okay, so this is about the various part of instrument of flame photometer. Major part of the instrumentation, that is interference. Numbers of factors beside the analyte affect the intensity of emitted radiations. The analytical signals often include contributions from constituent other than analyte termed as interference, and are found to interfere the outcome of the procedure. Various kinds of interference like spectral interference, ionization interference, chemical interference. Okay, so these are the various interferences. In the chemical interferences, there are also they are also classified as cation interference, cation anion interference, oxide formations. So these are the various kinds of interference. Limitation of this flame emission spectroscopy, that is, as a natural gas and air flame is employed for the excitation and the temperature is not high enough to excite the transition metals, and therefore the method is selective towards the detection of alkali and alkaline earth metals only. Low temperature make this method susceptible to certain disadvantages, most of them relatable to flame stability and aspiration conditions. Fuels and oxidation flow rates and purity, aspiration rates, solution viscosity, these all factors affect this thing. FES is the means of determining the total metal concentration of the sample. It tells us nothing about the molecular form of the metal in the original sample. It will only detect metal composition in the sample, and only liquid samples can be used. We cannot use any solid or gaseous compounds. Okay. Various applications like quality control department, where the simple and quick determination of alkali and alkali earth metals is required. They have advantage of being significantly lower price than most of the other atomic spectrometers. Biological medical applications, notable applications are the determinations of the sodium, potassium, calcium and magnesium in the body fluids and other biological samples itself. In the food industry, we can determine the concentration of calcium as well as iron in the beer or any other beverages. Okay. Next part, that is atomic absorption spectroscopy. It is also called as AAS. It is an absorption spectroscopic method where the radiation from the source is absorbed by non-excited atoms in the vapor state. This A deals with the absorption of specific wavelength of radiation by neutral atoms in the ground state. Reliable of detecting over 70 elements with metal and metalloids. The theory and principle of this AAS, generally these techniques use the basically principle that free atoms generated in the atomizer can absorb radiation at the specific frequency. This AAS quantifies the absorption of ground state atoms in the gaseous form, and atomic atom absorb UV visible lights and make transition to the higher electronic energy level, and the analyte concentration is determined from the amount of absorption. You know about the energy diagram. Okay, so the concentration measurements are usually determined from the working curve after the calibrating instrument with the standard known concentrations. Fewer steps are involved in this AAS, that is liquid sample, formation of droplet. The sample is converted into the droplets, then fine residues, and next step formation of neutral ion, neutral atom, absorbs specific wavelength of the radiation from the hollow cathode lamp, and measurement of intensity of radiation absorbed by the neutral atom using the detector. Okay. You can see the schematic diagram of atomic absorption spectrometer. You can see the hollow cathode lamp, which is the source, then chopper, burner, monochromator, focusing conversion lens, photocells, and then after detector. So the extent to which radiation of particular frequency is absorbed by the atomic vapor is related to the length of the path traversed and concentration of absorbing atom in the vapors, and it also follows the Lambert's-Beard's law. You can see the proper technique. When the sample is converted into the droplets and goes into the flame, the particles directly attracted toward the detector, and so it can detect it directly. Okay, so here the simple phenomena of the AAS. Instrumentation, same as earlier we have already discussed that sharp line radiation source, here hollow cathode lamp, nebulizer, monochromator, detectors, and last interferences. Limitations and applications expensive. They have low precisions, low sample through output, require high level of operational skills. Sample must be in the solution or at least volatile, and individual source lamp required for each element. But various applications like it can use for determination of metal at trace level in the solution, determination of purity, presence of heavy metals in the body fluid, pollution of water by the metals, foodstuffs of or soft drinks and beer determination, analysis of geochemical exploration, for the minerals and soil, crude oils, petroleum products, plastics, all in all that in the all composition, and we can identify the metal composition in the particular components. Okay, so these are the various application for the atomic absorption spectroscopy. So these are the reference book for the for the perfect reading of flame emission spectroscopy and atomic absorption spectroscopy. Thank you for watching this video. For more updates, like, share and subscribe our YouTube channel Pharma Ignite. Once again, thank you so much.